Welcome back, class. If you are preparing for your jamb UTME or jupeb exam, this is one of those foundational topics where examiners love to set traps questions. Today, we are going to be breaking down physical quantities and their types, keeping it very sharp, very clear, and straight to the exam board guidelines. First thing first, what actually is a physical quantity? In physics, we do not guess, we measure. A physical quantity is simply any property of a matter or a system that can be measured and given a numerical value. This is a golden rule. Physical quantity is equal to your magnitude and your unit. Let's say, for example, I say that the mass of a body is 5 kilogram. The 5 there is the magnitude, and the kilogram there is the unit. So in physics, anything that cannot be measured, like love, hatred, your favorite color, since it cannot be measured, it is not a physical quantity in physics. Now, how do we classify them? The first major split is based on dependency. Fundamental and derived quantities are based on dependency. Think of fundamental quantities as building blocks. They are independent and cannot be derived from anything else. Jamb and jupeb expect you to know all the 7 SI basic quantities by heart. Your length, your mass, your time, your electric current, your temperature, your luminous intensity, your amount of substance, their units, and also their dimensions. Yes, the dimensions. This is what, as a jamb student, you must know. And also as a jupeb student, you are expected to know this. Then, on the other hand, we have the derived quantities. Derived quantities are just the combinations of fundamental quantities through multiplication or by division. For example, your speed equals to your distance over time, your area equals to length times length, and your force equals to your mass times acceleration. So you see that it's either you multiply or you divide fundamental quantities. That is where you have your derived quantities. Here is what examiners might likely take hold of. Under this classification, we have the supplementary quantities and the dimensionless quantities. Sometimes students get confused, thinking everything must be either a fundamental quantity or a derived quantity. Newsflash, it's not always so. But physics has a special category of pure geometry. These quantities, they are technically dimensionless because their unit will cancel out, but we still assign them an SI unit for convenience. There are only 2 of them that you need to know for your exams, which are the plane angles and the solid angles. The plane angle is measured in radians and the solid angle is measured in steradians. While the plane angle is only 2 dimension, the solid angle is for 3-dimensional angles. Another type of quantities is the dimensionless quantity. Apart from the supplementary quantities, the ratio of same quantity of unit will always cancel out. An example of dimensionless quantity is your relative density, where both densities are in kilogram per meter cube. We have relative index, where both are angles. We have strain, we have mechanical advantage, etc. So you see that This quantity, they are dimensionless. So the supplementary now, they are dimensionless, but units are assigned to them. Why the dimensionless? Their unit cancels out. We don't usually assign units to them. Finally, let's look at the classification based on directions. We have scalars and we have vectors. Scalars have only magnitude, like your speed, your distance, your time, and your work. They follow normal mathematics rule. You add them, you subtract them, you divide them, you multiply them like you do to ordinary numbers. But the vectors now, they have both magnitude and directions, and they obey what we call the vector laws. So vector laws are more complex than simple algebraic manipulations. Examples include displacement, velocity, acceleration, and force. Here's a quick exam trap for you to watch out for. Examiner like asking about mass versus weight. Mass is just a scalar quantity, just how much matter is in you, the quantity of matter, the amount of matter. But weight is a vector because gravity pulls it downward in a specific direction. Try not to never mix them up. So since weight has both mass and gravity, which is magnitude and direction, then weight is a vector quantity. Let's put our knowledge to test. This is a real past question. Which of the following is not a fundamental SI unit? A. Amperes, B. Kelvin, C. Radian, D. Candela. The correct answer there is C. Radian. Why? Because radian is a supplementary unit. Amperes is for current, amount of current. Kelvin is for temperature, and candela is for luminous intensity, which are all fundamental quantities, and therefore their units are also fundamental. So watch out for dimensional analysis. I would like to see you in the next video. Please like, share, and drop your comment in the comment section.